Paris, Charles de Gaulle Airport. Flight AF334 to Boston is about to take off. The terminal is all a bustle as boarding begins. In the cockpit, the two pilots carry out final preparations.
Fire test, all good.
Safety systems, fuel, weather, and route are all checked.
Westerly wind, 10 knots, so no restrictions. Visibility is good.
Check.
Everything has been checked and rechecked, and the 324 passengers are settling in. The Airbus A350 is ready to taxi. The aircraft accelerates and takes to the skies. 280 tons soar through the air. These are the things we take for granted. And yet, a smooth start like this owes nothing to chance. Within just a few decades, crossing oceans and continents has become the norm. Every day, 20,000 aircrafts crisscross the skies around the globe. For all this to work on a daily basis, the aircraft has to be kept in perfect condition.
No plane sets off without being checked, inspected, and verified by a team of mechanics.
Maintaining a fleet of aircraft requires extraordinary resources. In the front line are the massive hangars found at the heart of international airports to accommodate battalions of increasingly huge aircrafts.
We need to be able to replace an engine, deal with lightning strikes to the structure, and modify flight controls.
On the ground, armies of mechanics check, detect, and repair the slightest defect identified on an aircraft. In parallel, experts and workshops are equipped to carry out in-depth refurbishment of state-of-the-art equipment. In specially constructed buildings, crews dismantle and examine engines piece by piece.
Mechanically speaking, an engine is extremely complex, containing very small parts that need to withstand enormous stresses.
On the tarmac or in the workshops, how are these flying machines kept running smoothly? How is an entire fleet maintained to guarantee daily flights all over the world? Pilots, engineers, mechanics, and technicians all play their part. Thousands of people work together to make sure that aircraft gets off the ground safely. Paris is one of the most visited cities in the world. Every year, 100 million travelers pass through its two airports. To the south of the French capital, Orly handles 33 million passengers a year, while to the north, Charles de Gaulle handles 67 million. It is the largest airport in Europe. More than 455,000 flights pass through here every year with connections to 5 continents. 1,300 takeoffs and landings a day. More than 1 movement per minute. To ensure that this constant toing and froing runs smoothly requires flawless organization. But there's more. Before managing the flow of aircraft in the sky, each aircraft has to be checked to ensure it is in perfect working order and can transport its passengers safely. This is the fundamental principle that underpins global air traffic.
Our priority is flight safety.
Here in Paris, the notably at Charles de Gaulle Airport, the national airline Air France keeps a close eye on its 220 aircrafts to ensure they remain in impeccable condition. Boasting the latest generation aircraft, this regularly upgraded, ever-changing fleet requires constant maintenance, monitoring, and repair. It's an assignment for which Air France has unparalleled expertise.
We need to be able to replace an engine or landing gear or flight controls in the event of any problems and troubleshoot the aircraft in the Roissy area.
In total, Air France has a workforce of 7,500 spread over 4 sites and 3 huge logistics centers. Thanks to its expertise and key position in one of the world's largest airport hubs, the company is now responsible for the safety of aircraft flow by over 200 other airlines.
The Air France fleet comprises some 220 planes. When it comes to equipment maintenance, we're talking about over 3,000 aircraft worldwide.
To successfully meet the demands of this crucial activity, Air France needs to be able to act fast. And for their technical experts, the principal asset is the company's gigantic hangars just a stone's throw from the Charles de Gaulle airport runways. These strategic infrastructures are the first links in the aviation safety chain. A constant flow of aircraft passing through the examination by a battalion of mechanics. Among the hangars is the historic H2, dedicated exclusively to the Airbus fleet and able to accommodate 7 aircraft simultaneously. At this very moment, one of France's new long-haul flagships is about to be overhauled, an Airbus A350. The 25-meter-high doors open 100 meters wide to welcome this new giant of the air. With its 65-meter wingspan and 17-meter vertical stabilizer, the crew is on deck. They guide it carefully and precisely to its assigned zone. One of 7 well-defined places in the hangar.
On average, we handle around 30 aircraft a week. We have to juggle between available places and aircraft downtime. The planes stop for something between 1 day, 1 night, and 2 days. So we need to establish a rotation exercise to make sure that everything fits together the following week.
Hangar space is at a premium. Each aircraft has to follow a regular maintenance program, which must be strictly adhered to, including mandatory checks even when no problems are detected.
The radio altimeter, we said. Carry on with the card. That's all done.
Mechanics and technicians have to be organized around a daily schedule to attend to each aircraft within an allotted time. Today, the Airbus A350 Orléans is coming in for a Check A visit. This checkup is carried out every 1,200 flying hours, which is approximately every 3 months, with 2 days downtime.
Every day, we have to be in a position to meet our schedules, taking delivery of parts and optimizing tasks so that we can get everything back into service as quickly as possible.
On this long-haul aircraft designed to cross oceans with over 300 passengers on board, the mechanics are preparing to work night and day, in shifts for 48 hours to inspect the most critical parts of the aircraft. Flight controls, engines, electrical systems, everything that keeps the aircraft flying safely. Meanwhile, a short distance away on the other side of the hangar, another crew is tackling an Airbus A220, a medium-haul aircraft much smaller than the A350. The hangar technicians have just 24 hours to complete their work, and they are winding up their checks.
No marks on the glazing?
Yeah, all clean, no scratches.
After arriving the evening before, the A220 Sauterne is due out at the end of the day.
You're checking brake wear?
All good. Indicator out. The rest of the brake is perfect.
After inspecting the structure and engines, the crews carry out a final check on the computer systems, known as the avionics.
Can you pull the HMU Channel A battery in EPC-1 Delta 7, please? Thanks.
Specifically, this involves checking the equipment controlling the aircraft's predictive maintenance systems, which allow any potential faults to be detected ahead of the plane's visit to the hangar.
Tell me when you're ready.
Okay.
Set it to maintenance and we're ready. Modern aircraft provide a lot of information, much more than the older generations, data which is extremely valuable because it allows things like predictive maintenance. Today, we're able to anticipate a possible fault or potential failure of one of the aircraft systems and tackle it before it breaks down. So that's very valuable.
For these maintenance professionals, it's essential to anticipate problems and deal with them as quickly as possible. Every minute of aircraft downtime is important for a company operating over 1,000 flights a day. Away from the hangars, back towards the heart of the airport area, stands Air France's headquarters, home to one of the most sensitive divisions, known as the OCC, the Operations Control Center. It is a highly strategic location. This is where all the company's flights are managed. The operators here make sure that aircraft are available, crews are assigned to each flight, and departure and arrival slots are respected. They do their utmost to ensure that a scheduled flight actually takes off, despite the countless hazards faced every day.
Air transport is at the mercy of many factors: meteorological, geopolitical, geological, technical, IT, and so forth. So it's our job to steer our business through this obstacle course.
To achieve this, the Operations Control Center brings together experts from 17 different professions. More than 150 people are on duty around the clock. Airport liaison coordinators, meteorologists, regulator experts, passenger information specialists. They need to be able to adapt to any situation.
Decisions have to be made on the spot. As you can imagine, depending on unforeseen events such as the weather, things have to be decided quickly. Do we divert a plane? Do we interrupt operations? So it's really about a day-to-day situations and being able to validate a decision made in real time. A plane is delayed in New York because of a heavy thunderstorm and is 2 hours late. Obviously, this has an impact on the following flights in the schedule.
Issues pertaining to fleet maintenance and upkeep are obviously at the heart of the control center's decisions. Today, an Airbus 8220 bound for Stockholm is causing problems. The aircraft is no longer able to make the trip. The cause? A collision with a bird on its last trip.
The Papa November India fire?
Is it repaired?
No. It won't be ready for the 1462 Stockholm flight.
The aircraft has to be replaced as quickly as possible. The trouble is, the 5 reserve medium-haul aircraft normally used for last-minute emergencies are no longer available, having already been allocated to other flights over the course of the day.
I'll ask for it to be on the runway around 8 p.m. if possible to limit the damage.
The final option lies with the control center maintenance specialist. He has to assess activity in the hangar to try to save the situation.
Hi, Arnold. We have a problem at the OCC on an A220. I saw that Papa November Bravo is in. Do you think we could hurry it through and have the plane in the next 2 hours? Okay. Well, that should do it then.
Maintenance departments adapt their activities and do their utmost to ensure the smooth running of the flight schedule, and thus make any problems invisible to passengers.
We are constantly monitoring of the state of the fleet, so we can pick the best options to solve any problems that may crop up.
In the Air France hangars, this kind of schedule flexibility is essential. In addition to the usual preventive visits, the teams have to leave room for any unexpected urgent repairs caused by incidents on the ground or in the flight, requiring the rapid intervention of technicians, be it a collision with birds or more complex cases. Back in the H-2 hangar, the A350 Orleans is still receiving attention, and it seems to require a little more work than a simple routine check. The crew and the aircraft's detection systems have reported a probable lighting strike. As a rule, pilots and control center flight engineers alike do their utmost to avoid stormy skies.
In thunderstorms, you also have hail, vertical movements, and wind shear, quite a few phenomena. That's why we do our utmost during the flight preparation to avoid such zones.
Despite these precautions, aircrafts can still be caught by lightning during takeoff or landing. The phenomenon is of course foreseen by constructors who ensure that the fuselage is resilient and flight safety is not compromised. On the other hand, lightning strikes can create zones of fragility, producing weaknesses that need to be dealt with rapidly on the ground.
Lightning strikes the fuselage just as it would a tree on the ground, except it will be discharged and leave the plane. A problem that can occur, though, is that the impact and the high temperature produces a flaw and an entry point for the lightning on the aircraft.
The mechanic's first task, then, is to clearly identify where the lightning struck and what damage was caused.
Any news about the front wave? We've had a report of a lightning strike on the interior VHF antenna.
No area should be overlooked. No impact can be disregarded by the technicians. A lengthy and meticulous examination is required.
Yeah, I see it.
Right there.
It really took a hit. When an A350 is struck by lightning, it takes around 100 hours for technicians to inspect the entire aircraft, from nose to tail, examining all the areas that cannot be inspected from the ground.
A total of 4 strikes have been identified. 3 at the front on the fuselage itself, and 1 on a fin situated beneath the aircraft. At the first glance, the damage appears minor, but it actually affects a crucial part in the shape of an antenna that ensures communications with the ground. This bundle of electronics is far too sensitive to be kept in its current state and has to be changed immediately. The component is first disconnected from the electronics bay, then removed and replaced. While the antenna is being replaced, the other 3 impacts are being dealt with. Straightforward fuselage damage to be repaired before the next flight. Under these strange devices, the areas struck by lightning have been reconstructed and are now being heated by experts of a new kind. Plastergists have now been brought in as reinforcements to join the usual hangar crew of mechanics. Their area of expertise is the new generation of composites used to manufacture aircraft, which require special attention.
We work with carbon fiber aircraft, which are much lighter and stronger than what we had before. The downside is that it's a little more difficult and costly to repair.
As a general rule, a repair on a small lightning strike will take anything from 5 hours to 2 or 3 days to repair. It all depends on the depth and width of the impact.
The lightning damage has now been treated on site. After less than 48 hours, the Airbus A350 Orleans will be able to leave on schedule. But that's not always the case. Some repairs require much more extensive work involving operations that are impossible to carry out here at the hangars. In those cases, certain parts of the aircraft need to be dismantled. To carry out the most complex repairs, Air France has built a large-scale workshop just a few hundred meters from the hangars, the Helios building. Here, away from the hustle and bustle, 200 people are hard at work repairing damage to cabins, wings, or engine housings. These experts can handle traditional metallic components, no matter how imposing, as well as the modern composite materials now used in every nook and cranny of latest generation aircraft.
A composite is a combination of two substances with different properties, resulting in a material with a performance superior to that of the individual components.
Composites, then, are sandwiches of several types of material and, more importantly, several layers. A matrix acts as a support around which can be applied high-strength materials such as glass or carbon fiber using honeycomb cells, which are as light as they are strong. It produces a formulation that is lighter, more rigid, and can easily take on complex shapes. It all sounds perfect, except there is a slight drawback when it comes to repairs. And that's the challenge facing the specialists in this workshop. Sometimes, beneath what looks like a minor impact or deformation, the entire structure has actually been affected. In such cases, to carry out repairs, the whole area has to be dug out and rebuilt, layer by layer. Among the elements most often impacted are what are known as randoms, which is actually the nose cone of the aircraft, the section most vulnerable to any impact, however slight. For the specialists in the Helios workshop, repairing this section is a well-drilled activity.
The radome can first be placed in what is actually a mold, which helps maintain the part's curvature and preserves its aerodynamic profile. First, we remove the damaged part. Then we take the radome into the clean room to prepare the repair folds and rebuild the area that has been removed.
Once the impacted part has been removed, it must be carefully rebuilt to ensure the curves are identical to the original. After a few hours' work, the repair moves on to a key stage, which is curing. This restores cohesion to all the layers of the composite structure. The technicians take the part to one of the workshop's major pieces of equipment, the autoclave, which is a high-pressure oven.
All good for you, Thibault?
Perfect.
Can I pack up? Let's go.
The autoclave allows high pressure to be built up at high temperatures, making sure the pressure is evenly distributed over the whole part.
After 8 hours of rigorously controlled curing, the part emerges as good as new. The repaired areas are now incorporated into the structure, with the composite layers perfectly bonded to each other.
After stoving, we check that the repair has been properly heated and the folds properly compacted. And then we're done. The repair is validated. And at that point, the part can be sent for inspection and painting. It can then leave our workshop and be used as required to support the fleet.
In the event of damage, the hangar mechanics will be able to retrieve this freshly repaired radome from the spare parts warehouse, while dropping off the damaged part to be dispatched for repair. At Helios, at any given time, over 500 different components are in the workshop for repair, a process undertaken with calmness and expertise. These repair crews are essential to the day-to-day maintenance of aircraft, even more so when aircraft needs a more thorough checkup. Aircraft are then sent to the other side of Paris to hangar HN3 at Orly, a building specializing in operations that fall under the major servicing banner. In addition to the regular inspections, which mobilize the aircraft for no more than a few days, every aircraft also has to undergo a series of more extensive and thorough checks.
This is when an aircraft is brought into a hangar for several weeks so it can be thoroughly stripped down. We remove the side panels, floors, and cargo compartments. This gives us access to all the elements not visible during normal operations of the aircraft and allows us to check for corrosion on the fuselage structure and other elements, as well as cracks and elements that may be in need of repair.
These major stripping down visits are key milestones in the life of an aircraft. 16 years after entering service, the Boeing 777F is undergoing its fourth major service. That's one every 4 years for an aircraft with a very specific role. This is one of the company's 2 cargo aircraft, a Boeing 777 specially adapted for transporting goods.
A cargo aircraft has no passenger seats and is dedicated solely to transporting goods. Each plane can carry 100 tons of cargo.
On cargo planes, the interior of the windowless cabin is transformed into a huge hold, suitable for loading pallets. One of the major stages in the overhaul is thus a detailed inspection of the aircraft's loading deck, and in particular the attachment points on the huge reinforcement rails.
These fasteners are very important. If the cargo wasn't secured properly because a fastener was loose, it would jeopardize the safety of the aircraft.
See this?
It's deep.
Corrosion.
Sector by sector, meter by meter, the teams check the hundreds of attachment points and report any sign of a defect, corrosion, weaknesses, and cracks that could compromise load safety.
First fitting, a tooth is missing here.
Small impact on the rail. We'll write it down.
I'll make a note of it.
Once their inspection is done, the repair technicians can step in. This painstaking work is just one aspect of a major service. While the cabin is being inspected, beneath the 777's huge left wing, a team prepares to examine a particularly sensitive area, the fuel tanks. On the 777, as on many modern aircraft, fuel is stored partly beneath the cabin in the central tank, but mainly inside the giant wings. A total capacity of 180,000 liters is spread over the entire wingspan of the aircraft. This volume is compartmentalized to prevent any large-scale shifts of fuel that could destabilize the aircraft. It is a complex and highly sensitive area that needs to be 100% safe. Wearing a special suit that eliminates the risk of even the slightest spark, the inspection technician slides into one of the openings. He checks for wear and tear, corrosion, and ensures the high-tech equipment built into the tanks is in good working order.
It isn't just an empty container. Inside we have detectors to indicate the fuel level. We have a series of pipes to allow fuel to be transferred from one tank to another, so that the left engine can be supplied from the right wing and the right engine from the left.
Moving through the compartments, one by one, the team looks for the slightest anomaly. It will take them a full day to examine just one of the 2 wings. During these major services, every nook and cranny of the aircraft is scrutinized. Across on the other side of the aircraft, perched on the right, specialized technicians are engaged in a particularly meticulous assignment. Again, with extreme precision, they are closely examining the aircraft's structure, right down to the thickness of the materials. Their objective is to detect any signs of structural fatigue. Micro cracks and fissures can appear over time and need to be identified as soon as possible.
The aircraft is subjected to a great deal of stress, whether taxiing on the ground or in flight, and as a result, can often suffer deformations. The fuselage is subjected to pressurization and depressurization cycles, in addition to temperature variations ranging from 20 degrees on the ground to minus 56 degrees in flight. So all these conditions can generate stress in the structure and lead to fissures or microcracks at corners, around rivets, or at the seams. Let's look for cracks.
It's important to detect every micro crack as early as possible because what we can't control is whether it will develop into something larger and ultimately lead to an unwanted flaw.
Like a crack in a windshield, it will just keep growing until the structure ruptures.
Now I'm starting to see the defect.
The specialists in these structural tests scour the most critical areas of the fuselage and wing with a fine-tooth comb, centimeter by centimeter. By sending an electric current through the material, they can detect the slightest defect or irregularity and potentially the beginnings of a crack less than a millimeter in size.
Now we've got the flaw.
The crack is there. We were well adjusted.
Perfect.
Again, if a defect is found, it will be up to the repair teams to intervene as quickly as possible. These major inspections are painstaking, complex tasks that take several weeks, a period during which nothing is left to chance.
The organization never changes. It's important because it means we don't have to come back to the same task 10 times to make sure we've got it right.
In all, to go around a wide-body aircraft like the 777 cargo plane will take 10,000 man-hours, just for the inspection. Then another 8,000 hours for repairs. Repairs on the aircraft itself, beneath the wing, often require the delivery of replacement parts. But some parts require their very own overhaul, a refit from A to Z in specialized workshops. The powerful engines are without question the key component of any airliner. The centerpiece that can lift hundreds of passengers off the ground and propel them safely through the clouds. Back at Charles de Gaulle Airport, the Helios building is where Air France's extensive engine overhaul and repair program begins. First, the entire housing is removed. This includes all the parts covering the engine, and in the case of the very largest, like those of the Boeing 777, the gigantic front cowling that protects the fins. This 2-ton piece of metal needs to be carefully maintained. Guided by the Helios experts, the casing is carefully moved, positioned horizontally, and then inspected in detail. Here in this chamber, the jet engine's blades are made to rotate at full speed, over 2,300 revolutions per minute. The technicians not only check the housing for corrosion, they also closely inspect the condition of the inner lining. When the engine is started up, the blades brush against the inner face of the housing, leaving only a tiny gap for the tiniest possible layer of air. The surface of the coating needs to be flawless and perfectly smooth. As the wings and fuselage, this is again very precise structural work, essential for the safety of the entire aircraft. With the engine housing removed, it is now time to dive into the aircraft's inner workings. Back to Orly, the engines are settling in for a lengthy stay of some 2 to 3 months in a complex where the entire overhaul chain is housed under one roof. From all the Air France hangars, as well as those belonging to other airlines, some 250 engines a year are sent here to be overhauled. Inside this first 10,000 square meter building, dozens of workstations are dedicated to a particular type of engine. Here, experts specializing in a specific model are able to examine it from every angle, whatever the reason for it being there.
Are we good on your side with the seal?
Engines end up in our workshops for 2 main reasons. The first is preventative maintenance. That's a bit like having the engine or bodywork overhauled in your car. So after a given number of hours in the air, you need to dismantle the engine to inspect certain parts. Then there's curative maintenance, triggered either by poor performance or maybe after a bird strike. Then we occasionally have to deal with breakdowns, cases where we need to investigate the engine and identify the parts that no longer work.
Whether it's a one-off breakdown or a standard overhaul, the first step is, of course, a detailed inspection. A thorough examination of the mechanics using a device called a boroscope. This miniature wired camera penetrates the deepest part of the engine, like a surgeon's endoscope camera. The operator examines all the workings of the mechanics, having access to a detailed view of each part and identifies any potential defect. It's a first-hand glimpse into these mechanical monsters.
The engine is the aircraft's most complex component. It not only provides the thrust that keeps the plane in the air, it also acts as a small power plant, generating the onboard electricity. It is partly responsible for generating the airflow in the cabin, as well as driving the hydraulic power for the flight controls.
Once the inspections have been completed, the serious business can begin, and the engine is placed on a disassembly bench. Suspended above the ground, attached to a sturdy overhead crane, first the large modules that make up the motor need to be prized apart. It's a delicate operation that calls for extreme care.
Everyone in position?
Yeah.
The low-pressure turbine with its 2.8-meter shaft is removed.
Should I pull slowly?
Yes.
All right, it's coming.
We remove the turbine, which includes the transmission shaft that runs through the entire motor. This is the shaft that drives the fan blades, which are the fins you see when you climb aboard an aircraft. It's a huge operation in terms of cost, because if we damage the shaft, the part is worth something like $1 million. On top of that, we have what's called breakage damage, meaning we're probably going to have to inspect other parts and dismantle other modules because we've damaged the shaft. So the overall dismantling costs run into several million more euros.
A little more weight, please. There, that's better.
The technicians are very experienced and need to pass theoretical and practical exams before tackling these jobs.
Once the various modulus have been separated, the actual revision work can begin. The technicians dismantle the entire engine piece by piece. Thousands of elements, from smallest to largest, all as delicate as they are important. In the next building, the workshops dedicated to this meticulous examination receive the engines piece by piece. Every bolt is cleaned, tested, and cataloged. A few dozen meters away, gears are checked, assessed, and tracked. This extreme vigilance for every component of every engine, no matter how small, is crucial to flight safety.
We're dealing with very small parts that are subjected to extremes, both in terms of physical abrasion and temperature. Very small parts like these will potentially need to have tiny holes for cooling, while at the same time being subjected to forces of pressure.
Right at the end of this huge inspection string, the experts in crack detection intervene once more. And again, they're on the lookout for the slightest defect that could potentially grow and degenerate. Their technique of choice is dye penetrate inspection. The most sensitive parts are immersed in baths of fluorescent agents. This is followed by a series of washing, soaking, and heating operations to fix the dye into any slight irregularities present in the component. Finally, in the dark room, under ultraviolet light, the magic happens. The tiniest flaws are revealed. If there is the slightest doubt, the part is removed and replaced.
Once we have the status of all our parts, so we know which ones have been repaired, which ones have been replaced, and which have been overhauled, Then we have a whole preparation phase that involves recovering all the parts we need to reassemble our modules, and ultimately our engines.
After 4,000 hours of inspection, examination, and maintenance, a further 2,000 hours are needed to ensure flawless restoration of the engine. A piece of technology with thousands of meticulously reassembled components. Along the way, every operation is checked and rechecked. When the workshop's job is done, the safety of the world's aviation industry is at stake. Every minute, all around the world, 70 takeoffs depend on the reliability of these incredibly complex engines. Yet despite the rigorous procedures and unstinting attention of the technicians, there is no such thing as zero risk.
A general overhaul of the engine affects a lot of things, not only everything going on inside the engine, but also many of the parts that are reassembled outside the engine, such as pipes, bolts, and nuts, as well as the flow of hydraulic fluid or fuel. But in the workshop, we're not able to test the impact of all those operations to ensure there are no defects.
The engines are put to the test throughout their life at extreme temperatures with dizzying rotation speeds. Complete confidence and flawless reassembly is one thing, but paper certification isn't enough. So once out of the workshop, they need to be tested under conditions as close as possible to the real thing. It's time for one last trip to Charles de Gaulle Airport. This time to the Zephyr building, home of the great engine testbed. This building, the only one of its kind in France, is tailor-made to test, monitor, and analyze the behavior of engines running at full throttle. Alongside the preparation workshop, its main asset is the test cell, which runs the entire length of the building. At the center is the area where the engines are set up, and it is here that they will be pushed to their limits. On either side, huge ventilation shafts ensure a high rate of airflow while preventing the entry of any foreign bodies. Finally, the entire structure of the building is designed to resist the strongest thrusts and limit vibrations. Thanks to this extraordinary facility, the test bench teams are able to handle almost 500 engines a year. They have 24 hours in which to test each one. Today, a GE90-115 is about to be tested. And it isn't just any old engine. This is the hardware that powers the airline's Boeing 777s.
It's about 3 1/3 meters long, but 10 in diameter. So we're talking about a huge engine, the most powerful civil engine on the market.
Operations begin in the workshop beside the test area. The first 8 hours are devoted to preparing the jet engine. An hour before the test begins, it is ready to be directed to the test unit. Along a rail perched some 10 meters above the ground, the engine is guided slowly but surely into position.
It's a meticulous operation because an engine weighs several tons, and transporting an engine is no simple matter. So it takes around 45 minutes to cover what is really a rather short distance, no more than about 50 meters. We do it at low speeds to make sure we don't damage anything.
The jet engine is slowly moved along through gigantic doors to the test cell. At the end of its journey, it is secured in its final position, ready for testing. A device monitors its every movement, while providing power to accurately simulate the in-flight conditions beneath the wing.
The engine will be hooked up to what's known as the thrust balance, which will enable us to measure the thrust of each type of engine and also connect the engine to everything it needs to work, i.e. the motor needs electricity, fuel, and air.
Once all the connections have been completed, the cell is evacuated and the operators take their places in the control room. This is like a cockpit where it is possible all the engine's parameters can be accessed and monitored visually from every angle thanks to 7 adjustable cameras. The test can begin.
We have a testing mechanic who initiates all the operations on the engine. He's the one who decides when to accelerate, decelerate, start, and stop. And besides him, we have a test driver to oversee the whole setup.
For the next 8 hours, the testers will put the engine through its paces, building things up very gradually. After an initial run without fuel, to check for any leaks, the testers launch the running-in period, when the engine is started up at reduced speed to give the various parts time to settle. Finally, thrust, vibration, and balance are tested. Everything is scrupulously reviewed.
You can't have any doubts when you put an engine back into service. It isn't enough to say that the engine can provide a little under 115,000 pounds of thrust. You have to be absolutely sure there are no mechanical problems that might shorten its lifespan or reduce performance once fitted to the aircraft.
If all the tests are conclusive, it will take another 8 hours to get the engine ready for transport and finally send it off to its final destination, back to where it came from, beneath the wing of an aircraft. Meanwhile, alongside the runways, the activity in the hangars never slacken. Engines are inspected, the ones requiring overhauls are removed, while others freshly repaired and tested are ready to be remounted. A few connections, some final checks, and the aircraft are ready to take to the tarmac. Or almost. Not before a short detour to a special area, the ground test zone. An obligatory check after an engine has undergone even the slightest modification. Here, 2 specially trained mechanics take the controls for a very special maneuver. The aim is to check that the engines have been correctly installed beneath the wing.
Rossi Ground 350 to Uniform Victor Echo, RP1 at the DM. Hello?
We take the engine, mount it onto the aircraft, and check for leaks on every connection between engine and aircraft. Under no circumstances can an engine be released without checking all the parameters required to get the aircraft back in the air.
In the estuary 386, all good for the exchangers.
We do a real simulation, putting on the brakes, engaging thrust as if we were at takeoff, as if we were at cruising speed. Once all that has been validated, we'll be able to make the first real commercial flight with passengers.
Just a few meters from the runways, in a protected enclosure, the engines are started up while the aircraft remains firmly lashed to the ground. In the cockpit, the mechanics vary the power of the engines and check their behavior. On the ground, they ensure that each component is properly connected. The Airbus A350 Orléans is finally ready to leave the large hangar area and taxi to the terminal for a return to service. Passengers on flight AF334 to Boston are starting to drift into the boarding lounge. The immense maintenance work that has been carried out behind closed doors is drawing to a close. It's a long chain in which every link is indispensable.
A huge number of different checks are carried out by different people across a range of sites to ensure we are on top of safety.
Meanwhile, on the tarmac, just a few meters below, technicians continue their mission in the large hangars right up to the last moment. They line up at the edge of the runway to ensure that the flight goes ahead under optimum conditions.
No plane leaves without being checked, inspected, and verified by a team of mechanics.
45 minutes before departure, the crew is ready to board. They prepare to take over the aircraft by going around the plane. One last time, one of the two pilots reviews the exterior.
People might not go round their car before getting in, but we always go round the plane. If we make, say, 4 stops in a day on a medium-haul aircraft, we'll go round it 4 times. That's really a basic requirement.
In the cockpit, it's time for a final check of the flight's components.
47.6 tons.
Got it.
600 running.
A notebook is handed to the captain. In it is recorded the history of all the repairs carried out in the company's hangars and workshops. The craft is now in the hands of the pilots.
At the end of the day, a pilot is the guarantor of flight safety. He's given everything he needs to make decisions, including maintenance records. So in the end, it's the pilot's decision.
Boarding is complete. The decision to take off is made. The plane leaves its position on the apron and ground crews directed to the runway. Departure is imminent. As always, this flight will be the fruit of a colossal effort. No aircraft can take to the skies without the work of thousands of men and women behind the scenes.